Just about every program you write will contain variables. Variables are used in programming much in the same way that they're used in math class, to store values. The ability to store and manipulate information is the fundamental principle by which computers work, and it's a key concept in programming. In programming, information is stored in various data types, quite literally the type of data you're storing. For now, we are going to focus on three main data types in this camp: the integer, float, and character. An integer is a whole number, floats can be any decimal number, and characters are single keyboard characters. Alright, this time instead of manually editing the delay time with the delay function, we're going to use a variable. So let's get rid of this 1000 milliseconds. And the first thing we want to do when we use a variable is we need to initialize it. And what that means is the compiler doesn't know where to store the information of the variable unless you first specify what the variable is, what its name is, and what its data type is. Okay? So we're going to first initialize this function, or this variable. And there's two ways to initialize it. You can globally initialize it or locally initialize it. And for now, we're going to do the global initialization. And we'll talk about the difference between those later. But let's go ahead and start with the global initialization. So type in the very top of the program, we're going to type int, which is for integer. That's the data type, call for the integer. And then we're just going to call it integer x. And also to give it a predefined value, let's say that the integer x is equal to 0. Or rather, let's since we want to have a delay, let's have a delay for, again, 1 second. So 1000 milliseconds. Remember, it's in milliseconds. So int x equals 1000. So what we did is we initialized it with the integer data type. We gave it a name, which is x. And we said, and by the way, this name could be anything. We could call this name, Nick variable, and that's a perfectly valid variable name. But I like to keep my variable name short, so we're going to stick with x for right now. And then we used a single equals sign and set it to a value. So we initialized it, gave it a name. We initialized the data type, gave it a name, and gave it a value. So now, anywhere in this program, anywhere in the entire program, we can call this variable x, and it will have in its place, instead of the character x, it will have in its place 1000. So when delay looks for its argument, it sees x as the argument, and the compiler then routes the x's value to its location in memory, which we can talk about later, but it recognizes that x is equal to 1000. So the delay, as you could probably guess, is still going to be at 1 second. Go ahead and try this out for yourself. Also, what you can do is, now that you have this variable and it's used in the entire program, you can change its value and it'll change throughout the entire program. Because remember, the variable is storing information, and you can manipulate or recall that information anywhere in your program. So if I set this, if I now change this value, it's going to change the value in here, and the Arduino is going to respond accordingly. Go ahead and pause the video and see if you can get this to work. Change this value and see if it'll change how the Arduino behaves. Alright, before we move on, I just want to talk briefly about passing variables as arguments to functions. So when we passed x here to delay, we need to make sure that we're passing the proper data type to the delay function. So as before, we were passing whole numbers or integers to delay, such as 1000. And now we're passing this variable x. So we need to make sure that x is an integer, because that's the data type that delay takes as arguments. Sure enough, we did it properly here. We have used an integer that is, okay, it's 1000. And you make sure you also don't want to do anything like initialize a data type with the wrong value. So you're saying an integer x is equal to something that's not an integer. 10.4 is a float, not an integer. So this would also mess up the compiler. So we'll leave it as a whole number. You can check what type of data type a function requires by going to Arduino reference. So I'll Google that again, and let's see here. We'll go back down to delay, and it tells us a description, how to use it syntactically, and the parameters of the function. So the parameter is what do you pass to the function. You can see here it takes the number of milliseconds to pause as an unsigned long. And we'll talk about unsigned and also long if you want later, or you can come ask me. But what this does mean is you actually can pass it a non-integer value and it'll be fine. But you just want to make sure that you're always passing a legal value to your function, or else bad things could happen, or your compiler cannot recognize, and your program will not compile. So it's always important to know what data types your function requires, and that your variable is the proper data type to be passed to the function. Alright, for this next one, we're going to learn about floats and how they differ from integers. So go ahead and pause the video and get up a blank slate of the Arduino IDE, just the setup and loop functions by themselves, and resume the video when you're ready. So we're going to introduce a new function that involves printing to the screen, printing text to the screen. And basically what we're doing is we're telling the Arduino to carry out a process and then return values to what's called the serial monitor. So what does this mean? So let's go ahead and just do an example. Type capital serial dot begin and then parentheses 9600. So this is the beginning the serial stream between the Arduino and the computer. This is also another built-in function that we're calling. And you can tell that the Arduino recognizes it because it lights up in orange. Make sure you get all the capitals in the proper order as well, or else the Arduino will not recognize, the compiler is not going to recognize what you're typing. So once we begin the serial communication in the program, which only needs to be done once, which is why it's in the setup, we're now going to print out just a little message to ourselves. So we're going to type serial.print, and then we can put whatever we want inside of these parentheses, and you can make it a serial, you can make it a character string, or a character array, which is also called a string, and you put that in parentheses and then just type text. So we go ahead and hit upload. Compiling sketch, uploading, and done uploading. Now we go over here to serial monitor in the top right hand corner. Go ahead and click on that, and you'll see your messages, your message or whatever you typed in to the serial print statement now appears in the first line of your serial monitor. So let's now work with a different example, and I want to show you guys the difference between working with integers and with floats. So delete what was in between your serial print statement, and we're actually going to enter some arithmetic right into the print and see what prints out. So go ahead and type, let's see, 4 divided by 2. So it should be able to handle this statement inside of the print function. So let's upload that. And go to our serial monitor. Sure enough, we get 2. Okay. Now, what happens if I do 3 divided by 2? Let's see what happens here. Remember, we're working with integers here. The compiler is seeing integers and doing arithmetic with those. So if we take the integer 3 and divide it by 2, the compiler gives us a 1. Okay? And so why do you think this is happening? Well, I'll tell you. It's because when you are using integers, remember that the compiler is working with whole numbers when you're using integers. That's what it's assuming. So when you divide a whole number by a whole number that it's not divisible by, aka not a factor of that number, you're going to get some sort of decimal, right? So 3 divided by 2 is actually 1.5. And the compiler, once it carries out this math, 3 divided by 2, it actually automatically rounds the output of that. It rounds all of it down to a whole number because you did not specify what data type you wanted, and it assumed that since you're working with integers, you want to stay in integers. So that's the rule that it goes by. It's going to automatically round your number down. So what we need to do is tell it, hey, we are dividing something that's not divisible by the divisor, so we're going to use floats instead, which could give us fractions or, in this case, decimals. So how we do that is we can just put a dot right after 3, or you could put even at 3.0 or 00, or however you want to do it, and that lets the compiler know that 3 is actually a floating point number, and we'll be able to you can divide it now by something that is not a factor of it. So go ahead and try this out. 3 or 3.0. Let's see what we get. Alright, 1.5. Good. In any case, you always want to make sure you're using the proper data types when you're doing arithmetic, and to avoid errors like rounding, because that could definitely screw up data that you're trying to work with, or inputs and outputs. So just make sure that anytime you're dividing, in particular, that you're doing so with the proper data type. So I want to talk about what's actually happening when we're initializing and using these variables. What is the compiler doing, and what's happening in memory? Okay, and we're going to use this term called random access memory, or RAM. You may have heard of it before, like, oh, my computer has 4 gigs of RAM or 8 gigs of RAM. And what this memory is you can think of it as like it is to a toolbox as your hard drive is to a tool shed. Okay, and so if you're working on a building and you need a tool, you need to use a tool, it's much quicker for you to get the tool out of the toolbox than it is to walk all the way over to the tool shed and get it. Okay, and so that's kind of how the computer uses random access memory. It keeps it on hand. It's much closer. It's much easier and quicker to get to. And so the following discussion is just going to be about random access memory, which is used when there is a program that's running, and we're using variables like the ones we've been initializing. So memory consists of bytes and bits. They're divided into bytes and bits. And one byte has 8 bits inside of it. And remember how we were talking about those ones and zeros that make up like computer language almost, right? Computer speak. Those ones and zeros are now coming into play. That's where we're storing these variables. So you can literally think of when we're storing variables such as booleans, integers, and floats, we're actually storing bytes, and in those bytes we're storing bits. And the bits, I mean, obviously they're not all zeros as shown in the picture. They could be ones and zeros in different orders, and we'll get to that next. But yeah, boolean, integer, and float, just to name a few, are some data types that, as you can see, a boolean takes up 1 byte, an integer takes up 2 bytes, and a float takes up 4 bytes in the case of working with our Arduino. So just real quick, counting in binary, you can encode information using these ones and zeros And the counting system that was established way back when computers were getting started and these standards are being made is, as you can see, there's 0 for 0, they're all zeros, and then they start alternating. You store 1, and then a 1 and a 0, 1 1, 1 0 0, 1 0 1. This is how the computer is actually storing your information, and it can then manipulate the information by say subtracting 2 columns or adding 2 columns. We're not going to delve into how that process works, but we are going to talk about ASCII characters, because we're going to do an example on those right now, and we're going to get into the character data type in a minute here. And what you need to know about ASCII is that it's just kind of useful when working with the Arduino, because also way back when, the ASCII is a standard set in place by, I don't know, some American companies to encode serial and encode character data so that serial stream was possible. Remember how we were printing to the screen? That's made possible by ASCII characters. So if we go back over to our Arduino IDE, let's go ahead and print out an ASCII character. So remember, over in the slide here, the counting system actually starts at 0 starts at binary number 48. Oh, so let's go and let's type in a 48 here. Character. So we're initializing the new data type, character. The name is X, and we're setting the value equal to 48. And then we're going to go ahead and, remember, we want to do this just once because we want to see it print out one time, so we're going to put it in our setup function in between the brackets. We're going to begin the serial stream between the Arduino and the computer, and then we're going to print out the character X. And so what the compiler is going to do is it's going to say, alright, I need to print something out. What's the data type? Well, the data type they gave me was character. So then it's going to refer to its ASCII standard and recognize that an entry of 48 is actually equal to 0. So let's upload this and see what we get. And sure enough, we get a 0. So what happens if I increment that by 1? Let's see what happens if we go to 49. Sure enough, we get a 1. And if we will definitely work with ASCII and characters later in the week. So for your reference, you can go to, here, I'll bleed out some of this. You can go to ASCII, well, really just Google it, ASCII table. Google ASCII table. Go ahead and just click ASCII codes. Okay, so here, listed for us is the table of ASCII standard characters for ASCII. So we're not going to talk about maybe some of these symbols, but over here you can see are some important ones you might want to use at some point. You can see here, see 48, the ASCII 48 is a 0, and that goes up to 57. You get a 9. There's some other characters here. You can also get the alphabet, starting at 97 is A, and so on. Alright, and lastly, if you go back to Arduino reference page, you can find out the amount of data you can store in a variable if you go to the variable section and just simply click on a data type, variable type, and as you can see here, okay, so they're telling us about, you can see the specific encoding in the ASCII chart. So the characters are stored as numbers, but they are encoded in ASCII, so we just kind of went over that. But it says a data type that takes up 1 byte of memory. and stores a character value. So again, 1 byte, and this is just kind of important also because we want to always write our program as efficiently as possible. So just because floats are easier to work with, because maybe you wouldn't have to convert between a float and an integer if you're trying to do some division, doesn't mean you always want to use them because they take up more memory. So you always want to try to think about the least memory that you can use up, and as to increase your program's efficiency. Alright, lad. There's like 2 more things I want to talk about before we leave variables for the moment. The first is casting, or type conversion is also called. And what casting allows you to do is change from one variable type into another, and forces calculation to be performed in the cast type. Okay, whatever. So what this does, or how you do this is, so here's an example program. So the example program is just initializing an integer I and a float f, and it's going to say that a float f is equal to a floating integer, or a floating number 3.6, and I then, the integer, is going to be equal to, and then this syntax right here is the casting in action, right? And so what this does is it says the thing that's next to this, look at it like it's an integer. Okay, it's telling the compiler this. So the compiler is reading this thing and says, okay, f, okay, 3.6, good. It's giving a floating value to the float f, and then it reads this line and says integer I is equal to int. So whatever comes after this is an integer, and we know integers truncate. Every time if we have a floating point, we truncate it down to the next whole value. So 3.6, which is stored in f, is truncated to a 3. Okay, and so let's just for proof of concept, I wrote this up real quick. I did very similar thing here. I'm going to first initialize x in integer x and set it to 48, and then I'm going to have a float and a character on the side, y and z. And so I'm going to run it once in my setup. I begin the serial. I say, and this time I'm using serial.println, which is going to each time it prints out the entry, it's also going to add a new line after that. So it'll be a lot easier to read. So println, we're going to print out the integer first, and then we're going to say that our floating variable y is equal to, and then float, which is the type conversion. It's the casting. We're casting the integer x, which is 48. We're going to cast it as a float. So, and then we're going to store that value inside of the floating point y. And we're going to print it out. And then for z, which is our character, we're going to, again, convert by using the cast char in parentheses, and x is going to come after that. So the integer x comes after that. And we're going to print that result out. So let's upload it. And it was already there on the screen, but just to make sure I'm not lying to you guys. Let's click our serial monitor, and sure enough, we printed out. First, we printed out x, which is the just integer x, or integer 48. Then we converted it to a float, stored that value in the float y, and printed it out as a floating value of 48, with 2 decimal places, so that worked. And then we did conversion to a character and stored that result in z. So, and then we printed it out, and sure enough, remember from the previous discussion that ASCII numbers start at 48. 48 is 0. So our conversion worked. We got a 0 here in ASCII text. So that's a good intro to variables. The one last thing I do want to talk about is you'll remember at the beginning I was talking about initializing the variables, and we said that this is okay for now. This is called global initialization. So these are being initialized. These variables are being initialized outside of our program, outside of our main setup and loop functions. So anything in this entire program can edit your variables. And we'll show in a little bit why that can be dangerous sometimes, because you can lose track of how your data is being manipulated, and sometimes you could really screw up your program if you lose track of your variables, which is why local variables come into play. But for now, just remember that we're using these global initializations. They're not totally the best thing, but we're going to use them for now just for ease of use. Okay? So let's move on to the next section. Up next are conditionals.